Well, good morning and welcome to where we finally get to do some things with the actual coordinate planes, but that's because now we know all about integers and rational numbers. So this lesson is how to construct a coordinate plane and some other things about the coordinate plane, and you need to be pretty precise with some of this stuff, okay? You can't have willy-nilly lines that just go wherever you want. They have to be on the line and precise. It's just part of the rules. So you just kind of locate the center. And we'll talk about that in a minute. And then, oh gosh, do your best. If you sometimes struggle with making a straight line, find something that is straight, like the barrel of this pen, and then you can just follow that. Or you could borrow a ruler or have your own ruler. That'd be cool. Okay, so the line that goes up and down is called the y-axis. And it's a line, and so it has to have arrowheads at the end because technically a line goes on forever in two directions. And I generally label it at the bottom. You could label it at the top, but you should always label it. And then locate the center, and we're going to have our horizontal axis. Do you know what our horizontal axis is called? I do better from left to right, so I'm going to do that. Our horizontal axis is called the x-axis. And I labeled over here. Why over there, Miss D? Because it's mostly out of the way. Oh gosh, can you even see that one? There it is. Hello. Okay, because it's mostly out of the way. So you should have your paper or area now split into 4 pieces. And because it's in 4, that would be quad. And so this is called, right, your coordinate plane, but it has 4 quadrants. And of course, those quadrants have labels. This is quadrant 1. Then it goes counterclockwise. This one is quadrant 2. That makes this one quadrant 3. And this one quadrant 4. And they are always written in Roman numerals. Nope, I don't know why. Sorry, I don't know why. I've just never cared enough to find out why. Okay, so quadrant 1 is the one usually you've dealt in, probably as a small person, always in quadrant 1. Why? Because the numbers were always positive. You had your x, y. Steve, what's this funny language you're speaking? So inside the parentheses, you have your x coordinate, which is your how far right and left, and then your y coordinate, how far up and down. And they always are in parentheses and separated by a comma. Always. So you need to be sure to do that. So here you have a positive x and a positive y. Here you have a negative x, because if this is 0, 0, which is called the origin. Origin means like place of beginning. If that's 0, then you remember from our work last week and the week before that anything to the left is negative, and because this is the x-axis, that would be a negative x, and it's above the 0, and above meant positive. Boom. Look at all those words we used that actually were important. And then here we have a negative x, because we're still going this way to the left of 0, and we're going below 0, and the y, so we have a negative y. Ooh, I hope you're guessing at what this one is. What do you think this one's going to be? All right, let's find out. Okay, so we're over here in the positive x area and the negative y area. What's all this mean? Well, the more experience you have, and therefore the easier it is to remember these little tricks. They're not tricks, but those little facts. When you see a point that should be plotted, then you know immediately what quadrant it will be in. Why does that help you? When you have to compare things or when you have to translate things. Not our normal translation where we go from one language to another later next year and the following year. Ooh, maybe we'll try some this year. Anyway, translations of figures in geometry is actually moving those dots and reflecting them across an axis. Let's not get into it. It's just too much for us right now. let's just continue on with this. So we labeled the origin, we labeled all the quadrants, we talked about how to write a point that you need to plot. Maybe we could practice writing some. So randomly, oh man, I know what we haven't done. We haven't put a scale on our axes yet. Let's pretend each one is worth 1 because, well, that makes life easier. That's a 1. And we're labeling the line. 6th graders have a real problem with this, and they'll try to just label out here in the middle of this bar. We're not creating a bar chart. We're labeling the line because we need to know where those lines intersect. So let's not label every line because that's too much work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we go this way. Remember negative. Ooh, -1, -2, -3, -4, -5, -6, -7. If you want to pause me right now and continue on with both of them, awesome. Or you could just mute me until you see me doing what I'm going to do. But if you need me to talk to you, I'm going to keep talking. -8, -9, -10, -11. And then I'm going to label these ones on the even. Why? So I just don't get too cluttered here with stuff. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. I feel like I didn't do a good job of centering my x-axis. That's all right. -9, -10. The scale won't always go by 1. What determines your scale is how much information you need to fit here. So if I had a point I needed to plot that was 50, 4, I would need this to go clear out to 50 without adding 5 more sheets of paper. So if that was the case, I might make every one of these lines worth 5. But I would need to do that all across the x-axis. If the scale here is going to be one line is 5, then the next line is going to be 10, 15, 20, etc. And then backwards, -5, -10, so that the scale stays the same. The scale can't just change willy-nilly. The scale on the x-axis can be different from what happens on the y-axis. We'll learn more about that when we do a statistics course, but you want to pay attention to how the scales are labeled. All right, so let's just plot some points here. How about this point? And this point? And, ooh, this one. And let's do this one, clear over here. And then let's label them. So first thing when we have a label is we're going to need the parentheses and the comma. Sometimes I like to just go put those in so that I know, oh, I lost that one. I know what I need to fill in because all coordinates are going to be written in the XY format. So let's do this one. Okay, let me see. Over 2 is my x-axis, and then up 1, 2, 3, 4, 5, up 5. Okay, so 2, 5 is how I would say that. Let's do in quadrant 2. Over first. Ooh, do you want me to make a note for you? Okay. So when you're making your quadrants, your X comes first, then your Y, which is over, then up. I really try to remember it that way because it helps me. And it always has. All right, X. 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left of 0 is a -9, and then up 1, 2, 3, +3. Okay. 1, 2, 3, 4 to the left of 0 is -4, and down 1, down is a -1. Okay. Oh gosh, we got to go clear over here. Ooh, it's not labeled, but it's only 1 more than 11, so it must be 12. And then, oh, we're going down. Ooh, so I know that's going to be a negative. 1, 2, 3, 4, 5, 6, 7. Boom. Okay, so that's basically what you need to know about constructing a grid. So in summary, the axes, Y goes up and down, X goes left and right. Arrowheads and labeled at the ends because they're lines and they go on forever. Your scales, okay, your scale on your x-axis needs to stay the same and your y-axis needs to stay the same throughout the whole axis. Quadrants, 1, 2, 3, 4. Always write your coordinates in an X, Y format. So over, then up. Copy? I think that's it. All right, good luck, guys.